Hi, we are from Team Saviors, and my name is Wai Hong. Let us start our presentation. The future is EV. There's a mass adoption on electric vehicles, and it is becoming more commonplace as the world marches towards a greener future. As we want to introduce an energy sustainable future, we will need to adopt electric vehicles, including Singapore. We know that LTA strives to deploy 60,000 EV charging points by 2030 and to completely phase out internal combustion vehicle by 2040. However, as the adoption rates of electric vehicle gradually picks up in Singapore, we cannot deny there are risks in high voltage charging. When we deploy EV chargers in a mass scale, we must always expect the unprecedented. But what are the risks? Let us assess. So we know that from overseas experiences, there's a vulnerability on catching fire and explosion during high voltage charging. And it is more challenging to put out high voltage fire. And if you look at statistics, it shows that lithium-ion batteries have the potential to explode or burn. And Tesla even warned first responders that it can take 24 hours to actually extinguish a battery fire. So we know what are the risks of EV charging. Let us break down the problems by phases. Imagine today, James owns an electric vehicle, and he has been utilizing public charging points to actually charge his vehicles around Singapore. However, James is unaware there's a battery fault in his vehicle, and this is common because battery anomalies are often undetected during charging. And this is because there's a lack of in-depth analysis on EV charging behaviors. And James will be left without any indication should there be a battery fault. So James is unaware, and he continues to charge his vehicle around Singapore, and finally, one day the flashpoint occurs. And because a typical electric car would take around 8 hours to be fully charged, it could result in a delayed response due to unmanned charging. And we know that battery fire escalates very fast, and this could result in an increase in property damages, especially the other nearby charging vehicles. Finally, SCDF arrives. However, the challenge is compounded by toxic gases being emitted from battery fire. This increases the risk for first responders, especially when there is a battery thermal runaway. And due to the lack of prior data, it makes high voltage firefighting very challenging. We know that EV firefighting are highly dependent on battery placements, battery composites. As we look at overseas experiences, firefighting units are actually still trying and experimenting different counter methods for high voltage fires, including there's a team that tries to use fire blanketing to control the fire, and there's even a team that tries to submerge the whole vehicle into the water tank just to try to control the fire. So now we know that EV firefighting is unprecedented. How might we perform early detection on anomalies on battery? And to enhance emergency response, strategize EV firefighting, and to create an unmanned situation awareness during EV charging. Hence, we propose you Safe Charger, a smart EV charger that enables early and efficient response to fire caused by EV charging. How does it work? The proposed workflow for EV charging starts with IoT and automation-enabled sensor aggregation, as well as an emergency response system. Once all these sensor data are consolidated, we will utilize AI capabilities to render situation awareness, anomaly detection, as well as metadata consolidation and analysis. Machine learning will be able to distinguish the severity of the situation and channel a calibrated response to relevant authorities. So in a case there's early detection on charging anomalies, we will then route the response to the vehicle owner, manufacturers, as well as assign third-party assessment vendors. However, when there's a fire, it will require the help of SCDF, as well as other fire alarm system vendors. So let's talk about the hardware. The Safe Charger is actually equipped with RGB and thermal imaging, voltage and current sensors, as well as gas composite sensors. And all this data will be fed back through IBM Cloud. We know that first layer safety response and first layer intervention is important. Hence, we leverage on automation technologies to actually introduce a modular emergency fire sprinkler system. And we know that we have put on mechanical considerations to actually make this system as modularized as possible. However, where does the sensor data goes, and where are the AI capabilities being reflected? We will introduce you Safe Charger Remote Dashboard. Let us take a look at a video on how it works.
Welcome to the Safe Charger Dashboard. There are 4 different sensor graphs: gas, temperature, voltage, and the warning level. The blue line is the live data points. The orange line is Tier 1 threshold, which will inform the vehicle owner and third-party assessment vendors if hits. The red line is Tier 2 threshold, which will inform the SCDF first responder if hits. In this scenario, the blue line has crossed the orange line. Vehicle owner and third-party assessment vendors are alerted. Live feed of the vehicle can be observed through here. The heat map of the vehicle can be observed from thermal camera. The details of the vehicle, such as the model, type, and battery placement, can be found in this page. Using the specification data, the machine learning model will gauge the severity level using predictive analysis.
All right, now we know how Safe Charger works. Let us walk through a simulated scene on how Safe Charger will react to emergencies. In the event of a car battery fire, the hazard will be immediately detected by Safe Charger, and emergency response will be pushed through the remote dashboard. And as you can see, the sensor data actually exceeds the severity level. And with this, in the event of a battery thermal runaway, it will also be informed to SCDF personnel. And SCDF would then be able to tag on thermal imaging footage, as well as to extract car specifications and battery models that is detected through the machine learning model. And prior to SCDF arrivals, the emergency fire sprinkler system would then try to control the fire by an extinguished medium. And finally, SCDF arrives. They will be able to assess the data that was extracted through Safe Charger and quickly assess and optimize the fire situation. And with this, we know that the fire situation is being controlled. However, this could be one of the emergencies that could happen around 60,000 EV charging points in the future of Singapore. Hence, we leverage on IoT, automation, and AI to actually have control over EV charging points and to keep relevant personnel informed. Most importantly, to intervene in the nick of time. So let's talk about our deployment plans. We actually plan to roll out these chargers at higher risk settings, especially places like hospitals, manufacturing plants, or even PSA ports. However, we have to convince them to actually deploy such safety systems. We actually considered a few range, and one of the problems we want to address is the technical compatibility, especially when there are so many EV charging points that are abundant in the market, as well as existing infrastructures that are being set up. All right, we know that most charging points are actually equipped with payment systems. Hence, we will be able to tag along the existing network pipelines to actually feed back our sensor data. And we have to adhere to certain standards for EV chargers, such as the Open Charge Point Protocol, which is a software protocol for sensor transmission. And we can actually modularize our mechanical and sensor add-ons to enhance the technical compatibility of our charger. So let's talk about the deployment incentives for infrastructure providers. So once we are able to extract car model and battery specification, we can provide insights for dynamic load balancing. And we can optimize charging cycles to save costs for energy tariffs. And we could help infrastructure providers to prevent over-congestion in power supply. So we know infrastructure providers is okay with it. It requires, to roll out this solution, it requires a seamless collaboration between different government agencies. We know that there's definitely value added for SCDF. We have to carefully assess the value added for different government agencies. So we know HDB could be one of the largest players in terms of deploying EV chargers. Hence, we could help them perform property damage control on different infrastructures adjacent to charging stations. As for LTA, we can provide important historical data on different vehicles and their charging behaviors. As for EMA, we can help them to provide load management on power grid consumption to prevent an energy spike. Now, it seems that electric vehicle adoption is inevitable for the future of Singapore, but we must never compromise safety. Hence, Team Saviors is here to provide you Safe Charger, a solution that can save energy and save life, and to keep EV fires in charge. That's all for my presentation. Thank you.
At this time, ladies and gentlemen, we will invite members of Xavier's to move on to the Q&A segment. Once again, with our panel of judges. So at this time, judges, if you have any inquiries, concerns, or questions, please grab a microphone and speak to Team Xavier's right now.
I'll go first. Good presentation. I like the graphics. You almost convinced me not to buy an electric car. Okay. But just a few questions, right? A couple of questions, actually. One is, have you done a cost benefit of this proposal?
I'll try this one. Testing. All right. So if you don't mind, we will show you a BOM of our cost analysis, and maybe we can we still show the slides? Okay. So actually, we did cost evaluation, and then we know that we actually taking on smart DC fast charger, which costs around 50,000. And with all the emergency modular mechanical add-ons, it increases at around 50,000. However, we know that one EV charger would cost around $33 to actually be fully charged. That's the sort of the incentive for the EV charger providers, right? So it takes around 400 plus vehicles to be charged to sort of break even, and 15K is just the first module that you install. As the charger cost, as the deployment increases, the charger cost can be scaled down by 15%. And this is actually around less than 10K extra from the current 50K EV chargers. And because of our technical compatibility, a lot of setup doesn't need to be redone. Once the charger is there, we can actually tag along the infrastructure. Yep.
Very good. I'm glad that you have thought through the cost benefit from I guess from this case here is actually from the provider of the charging terminals and all that, right? The only dimension I will also ask is, how big a problem is this? As in catching fire for electric vehicle upon charging. Yeah.
So in Singapore, fortunately and finger crossed, there's no EV charger fire incidents. However, in overseas, there's an increased rate, especially in US. We have seen especially when there's a faulty battery in a certain model, it escalates very fast because all of the vehicles share the same battery model. So once using a safety enhanced system in an EV charger, we can actually realize that, certain car models actually has a faulty battery very early. And once we know that, we can intervene as soon as possible. So the problem for one vehicle catching fire might not be a big problem, but when it comes to a mass adoption, especially by 2040, all vehicles are EV, and then this will be a large problem as it escalates. Yes, thank you.
Okay. So, good answer. It sounds like you have taken that into consideration. The only point I'll make is that there are continuous improvement that's happening from a battery perspective. So if that becomes much better batteries out there as they deploy more of electric vehicle, your business case will become a point of diminishing returns, right? Because it just doesn't make sense to deploy this. I think that's a consideration that you might want to take into account.
Okay.
Yeah.
Yep.
Okay, thank you, Xavier. Good presentation. Yeah, I'm convinced to buy a EV vehicle. I'm looking seriously into it now. And I just want to also add on to Mr. Tan's point about the continuous improvement. Prevention will always be better than cure, you know. And the other thing to look specifically about this problem, right, is usually, right, if you look into closer details about overseas incident of EV fires, right, they are not during the charging. The vehicle don't catch fire during the charging. It will catch fire when it's driving or during a crash situation and things like that. So these are the times that the vehicle will be in danger of have the thermal runaway situation, as you mentioned. Yeah. So at the charging point, generally it will be relatively safe. Yeah. So this is another case that you need to consider when you want to introduce this safe charging system. And the other thing, I'm glad that you look at the mitigation system. You know, not just collecting data. You know, there's an emergency, what's going to do and stuff like that. The point that you highlighted, right, to immerse the whole vehicle into a water bath That's necessary because you want to stop the reaction from happening. So your proposed solution of a sprinkler generally will not do much to extinguish or even much help to reduce the fire. Yeah.
Hi,
So
good
so
morning.
you must think about all this because to introduce sprinkler you also need to add in a cost. Yeah. Okay. Thank you.
May I answer that question about the sprinklers? Yeah, so actually for the sprinklers, right, we're actually looking at two different mediums. One is in liquid form and the other is in powder form. So actually we can modify the sprinkler system based on the needs and requirements of SCDF when they eventually decide and lock down the preferred medium to extinguish this kind of battery fires. From our conversation with our mentor Dinesh, right, seems like it's not locked down yet because also right now the adaptation of EV is not very high currently because it's like more of a future long-term plan. So actually our sprinkler system we can modify I just want to say we can modify the medium in order to suit the effectiveness of quenching the battery fire at the onset. Thank you.
And to add on from that, actually, if you can see, there's this box at the back. From the, oh, they cannot see it. Okay, never mind. Actually, we tried to introduce also a pressurized module, which we included in the cost. So actually, we know that fire sprinklers from the ground might not be effective from the top. So a pressurized module was one of our considerations to actually sort of create effective fire control. We are not trying to extinguish the fire, but we want to control the temperature before SCDF arrives so that the fire does not escalate to a battery thermal runaway. Yep, that's our idea.
Just one or two questions from me very quickly. I really enjoyed your presentation, very clear problem definition. But as a car owner, I would love to understand how your solution can actually help me prevent the fire from happening. I understand your point of view around containing it and managing it. And I was curious, what is the go-to-market strategy for this solution that you have? Have you thought about it?
So we have different stakeholders. I think we are clear with how we can help SCDF. As a car owner, I think we have mentioned that we can detect battery anomalies. So this is during the prevention stage, not the mitigation stage. So once you are using this safety system to charge a vehicle, if there's any battery fault at the early stage, it actually detects and informs the vehicle owners as well as the third-party manufacturers. So with this, you want to actually utilize some that has this extra feature to actually assess, okay, maybe when I charge, if I can be notified there might be a battery fault in certain stages, then I would choose this instead of a normal battery charger. And this is for the stakeholders, for individuals. As for infrastructure providers, why do I want to adopt this? That cost me an extra 10K. So with this, because we can help them to actually beat energy tariffs with all the data we provide to them, with this they could actually save costs. We do not have an actual cost because it might scale up when EV charging points are deployed in a mass scale, 60,000 EV charging points, the dynamics would change. However, as long as we can save them cost and it doesn't cost a lot to actually break even, this we will be able to convince infrastructure providers. And for SCDF, there's definitely value added. Yep, that's our considerations. Thank you.
All right, with that said, a big thank you to the judges and, of course, our second team of the morning. Let's give Xavier's another big round of applause, please, as they return to their seats for the next segment. Yes, I'm sure everybody enjoyed that presentation. Tesla Singapore also owes you gratitude as well. I'm sure already we have some interest from our judges. Yes, very exciting times indeed for the EV scene. But right now, as all three gentlemen return to their seats, I do have those words of appreciation from your mentor. So please sit back, relax, and enjoy.
Hi, Team Saviors. Right, first off, great presentation. It has been a pleasure mentoring you guys. And in the amount of time given, you have done remarkably well. So no matter the result today, you guys can be immensely proud of your efforts, right? And I also like to take this opportunity to wish you guys the best of luck in all your future endeavors. Thank you.
All right, that was absolutely splendid. Thank you so much, sir, for hopping on to that call. Once more, in regards to those words of appreciation for team number 2. Well done once again. Now, at this time, to our dear members of the live audience, we are again presenting you with the QR code slide. Just in case if you might have just missed out on any of the opening portions of this